In this video, I will talk about sets, and there are different topics in this class of sets. The first topic is set roster notation. Set roster notation. Since we encounter sets in our daily life, for example, if you want to have a set of furniture, then you can write chair, table, etc. If you want to have a set of fruits, then we have apple, banana, and so on. Okay. So similarly, we also have a set of numbers, set of natural numbers, set of real numbers. So we must have some notation to represent them. So there is a particular notation for writing a set, and that notation is you write a set in curly braces. For example, you want to show that positive integer, then we have 1, 2, 3. This is called set roster notation. If you want to write a infinite set, then we must have, for example, 3 dots after the last element, and these 3 dots are called ellipses. These are called ellipses. So uh, if I give you some example on that, uh, for example, we have a is equal to example. If we have a is equal to 1, 2, 3, and b is equal to 3, 1, 2, and c is equal to 1, 1, 2, 2, 3, 3, 3. Now the question is how many elements are there in each set? Here we have 3 elements. Here we have 3 elements, and here, although the elements are repeating themselves, but it is only 3 elements. This is 1, 2, and 3. So there are 3 elements over here, 3 elements. And these are, the order does not matter over here in the set. Here we have 1, 2, 3. Here we have 1, 2, 3. And here we have 1, 2, 3. Then we have 1, 2, 3, so on. So uh, that's how we write the roster notation and how we count the elements. Now the next example is if we have, for example, can we say that 0, the set which has 0 is equal to 0? The answer is, are they are equal? The answer is no. The reason is, on the right hand side we have a number. So I should write it formally. They are not equal. They are not equal. On the right hand side we have 0 as a number, and on the left hand side we have a set which contains one element over here. Another example, how many elements are there in this set? You can see that here we have one element 1, and there is another element which is not a number, which is a set. Okay. So how many elements are there? Element number 1, element number 2. We are not concerned how the elements look like, but we are only looking at the elements only that can be a set, which is a set, which is a number. So there are two elements in this set. Okay. Next, there is another definition which is called set builder notation. Set builder notation. So in set builder notation, we write a set like this: X belong to S such that P depends on X. Here, I need to identify some of the unknown things. The first thing is S is here, it is a set. P is the property. It is a property of elements in a set. Then we have this notation, a symbol, this one. This is called member of or element of, and then there is one, this vertical line. This vertical line is called such that. So there is more things to remember in set builder notation. So that's how we define set builder notation. Let me just give you one simple example over here. Example. If I write, for example, X belong to real number R such that X is -2 to 5. This is one example. It means that if you want to write a set like this, then you cannot pick -2 and 5. These are not included in the set. But it says that all the other elements other than -2 and 5, that these are real numbers, must be included over here. Another example, if you say that X belong to Z, which is integer, such that X is -2 to 5, this can be written in the set form since these are integers, so we can write this as -2, -1, since -2 is not included, -1, 0, 1, 2, 3, 4. So this is the set of above question which was written in set builder notation. Here I did not write this in the form of a set since these are real numbers and real numbers are too many. One thing we can do is I can write this as in open interval -2 to 5. So we are talking about sets. The next topic is subsets. Subsets. The subset is if you have two sets, A and B are two sets, then a subset of B means that for every x, if x belong to A, then x belong to B. So A is a subset. So every element of set A will be a part of set B. If it is written like this, that's how you define the. There is another definition of proper subset as well, but we will talk about that later. So in this case, if you want to visualize that, then we have a set A, the set B, which is bigger set, and then we have a smaller set A, but that can be equal to A as well. The same set can be written like this. In subset, this is the case. So there is another definition, that is the proper subset. Proper subset. In proper subset, we do not have an element of subset which contains in A. Let me write it properly. A is a proper subset of B if and only if every element of A is in B, but there is there is at least one element of B that is not in A. So that's what I was talking about verbally, but this is in written form, that we have A is a proper. We write this without any line over here. We do not write line over here. A is a proper subset of B. In that case, there must be one element in B that is not a part of A. So it means that we have a bigger set, which is B, and strictly A is a smaller set, but there is no element of B which is a part of A. Okay. So let me just give you some example over here. Example. Suppose we have A is equal to Z positive. It means that the set of all elements which has positive numbers, and B is n belong to Z and n is 0 to 100, and C is 100, 200, 300, 400 and 500. The first question has been asked is B is a subset of A. This is first question, first part. So this will be a false. The answer will be false. Answer is false. Since 0 is not a positive integer, therefore B is not a subset of A, since there are more elements in B than A. The second part is B. C is a proper subset of proper subset of A. C is a proper subset of A. If I just look at the C has these elements and it is a proper subset of A. Yes, it is a proper subset since C has less elements and there are many elements which are not uh, part of C. So C is a proper subset. The answer is true. Answer is true.